Hello, my name is Santiago Villazón, and today I will be talking about the final presentation video for the Simulink suspension simulation. First of all, as we can see on screen, we can see the Simulink diagram, which has all the matrices and everything so that the model works. Here we can see in this first graph for the state space model displacement for both masses on the graph, we can see that they have a similar pattern but different values. For example, for the yellow one, which is the unsprung mass, is really little compared to the sprung. This basically tells us that the least affected mass, which would be the user, which is the unsprung mass, will be the least affected when going through a pothole. And that's what we have. We have a little disturbance, and then we have a continuous line until the unsprung mass just reaches a stability. Contemplating the simulation with an interesting perturbation. First of all, I added a little pothole, as we can see in the graph. And explaining this graph, basically we can see that as it's a kind of big speed bump, once the car reaches, it has a very high first impact, which is the yellow line corresponding to the person, the unsprung mass, and then it just has a first big effect on the mass, and then it just gradually remains constant. After that, corresponding to how one could include or represent a semi-active suspension system in the state space model, basically this has to do with the matrices for the 4x4 matrix, depending on the displacement, this value here, the dampening coefficient. Because once instead of modifying, you just add another, for example, matrix, which will help you, create that semi-active suspension system. So yeah, that's basically it. Corresponding to the advantages and disadvantages of the system or product in an automotive system. Basically, for using the simulation, one of the disadvantages, first of all, could be that you can only see graphs, numbers, or just code, basically. You can't see an actual model of a suspension system, which kind of, you need more of a feedback from an actual physical like car, where you can get more values. And an advantage of this simulation is that you can kind of predict. I mean, you can't have the actual values, but you can predict what can happen, which is very important for economic purposes. After that, the way we organize the work is pretty simple. Basically, everyone in the team saw what had to be done. Everybody understood the assignment. Once we had that, we just everybody got to work. We just organized the groups in which we would work. One would do the Simulink, one would run simulations, etc., etc. We just basically divided the work, and everybody did their part, but everybody learned the same thing because we all did the document as a whole. Finally, sharing the achievement that I value the most in this course is that normally in schools, you don't get to see work, you don't, it's only theoretical stuff. You do calculus and stuff like that, where you don't actually get to see physical stuff. But with Simulink and this assignment, you can understand more thoroughly how a real life physical model works, just by seeing graphs, analyzing matrices, and state space models. Thank you very much.